Picture this. 3.4 billion years ago, Mars was a different world. It had oceans, an atmosphere, and maybe even life. Then, out of the cosmic darkness came chaos. An asteroid, massive and unstoppable, hurtled towards the red planet. The impact was catastrophic, releasing energy beyond our imagination. The asteroid, probably several miles wide, slammed into Mars at incredible speed. The collision sent shock waves rippling through the planet's crust. It vaporized rock and water instantly. A plume of superheated material shot into the thin Martian atmosphere. The ground shook violently, and the very shape of Mars was altered in seconds. The Mega-Tsunami reshaped Mars's surface as it traveled, and as the water receded, it left behind a changed world, one whose secrets were only now beginning to unravel. Fast forward to the present day. Earth's scientists, armed with powerful tools and advanced technology, turn their gaze to Mars. High-resolution images from orbiting spacecraft reveal something curious and unexpected. There are strange geological formations on the Martian surface that defy our current understanding. These formations don't quite fit with what we know about Mars today, suggesting a different past. These features hint at a watery past, but with a violent twist, indicating dramatic events. In 2016, a team of scientists made a groundbreaking announcement that changed our understanding of Mars. They had found compelling evidence of ancient mega-tsunamis on Mars, reshaping our view of its history. This wasn't just a theory or speculation. It was backed by hard data from Mars orbiters, providing solid proof. The scientists identified massive sediment deposits and unique landforms that were unmistakable. These could only have been created by enormous tsunami waves, powerful enough to reshape the landscape. It was like finding a fossilized beach thousands of miles inland on Earth, a truly remarkable discovery. For tsunamis of this scale to occur, Mars needed oceans, vast bodies of water that once existed. This added crucial evidence to the theory that Mars once had a wet, possibly habitable environment suitable for life. It opened up new avenues for research into Mars's past climate and potential for life, sparking renewed interest and exploration. But the story doesn't end with one mega-tsunami. As scientists dug deeper, they uncovered something even more astounding. There wasn't just one mega-tsunami event on Mars. There were two. These events, separated by millions of years, were caused by different asteroid impacts. The first mega-tsunami occurred about 3.4 billion years ago. It was caused by an asteroid impact in the northern lowlands of Mars. This event created waves that may have reached heights of up to 250 meters. The tsunami reshaped the Martian coastline, leaving behind massive deposits of rock and sediment. The second event happened a few million years later. Another asteroid, another impact, another mega-tsunami. This tsunami encountered a different landscape. These dual events tell us a story of Mars's changing face. They show us a planet in transition. To truly grasp the magnitude of these Martian events, let's look closer to home. Earth has its own history of cosmic impacts and mega-tsunamis. The most famous is the Chicxulub impact, which occurred about 66 million years ago. This impact, in what is now Mexico's Yucatan Peninsula, is believed to have led to the extinction of the dinosaurs. The Chicxulub impactor was massive, about 10 kilometers in diameter. When it hit, it created a crater 150 kilometers wide. The energy released was equivalent to 10 billion Hiroshima atomic bombs. It triggered earthquakes, volcanic eruptions, and yes, mega-tsunamis. These waves may have reached heights of over a kilometer in some areas. Section 5. Crater Hunters. Identifying the Martian impact site. Finding the smoking gun, or in this case, the impact crater, was a crucial step in confirming the mega-tsunami theory. But it wasn't easy. Mars has been battered by impacts throughout its history. Distinguishing one particular crater as the source of a mega-tsunami is like finding a needle in a cosmic haystack. Yet that's exactly what scientists set out to do. The search involved painstaking analysis of Mars's surface. Scientists used data from multiple Mars orbiters. After much searching, a prime candidate emerged, Lomonosov crater. This 120-kilometer diameter crater sits in a perfect location. The Lomonosov crater became the prime suspect in the case of the Martian mega-tsunami. Section 6. Waves of destruction. The magnitude of Martian tsunamis. Now let's talk about the tsunamis themselves and their immense power. These weren't just big waves. They were planet-altering events of colossal scale. The initial wave from the Lomonosov impact may have been up to 250 meters high. That's more than twice the height of the Statue of Liberty, an astonishing comparison. The wave would have traveled across the Martian Ocean at incredible speeds, almost unimaginable. As the tsunami moved, it would have picked up enormous amounts of debris along its path. This debris-laden wave would have acted like a giant watery bulldozer, unstoppable. It reshaped the Martian landscape as it passed, leaving a lasting mark. By studying these tsunami deposits, scientists can piece together the story of Mars's watery past, revealing secrets. Section 7. NASA's Watchful Eye, Monitoring Near-Earth Objects. The discovery of Martian mega-tsunamis isn't just about understanding Mars's past. It's a stark reminder of the power of cosmic impacts. And it raises an important question. Could something similar happen to Earth? This concern has led to increased efforts to monitor and track near-Earth objects, or NEOs. NASA is at the forefront of this cosmic watchdog effort. NASA's NEO observations program is dedicated to finding, tracking, and characterizing asteroids and comets that could potentially impact Earth. They use a network of ground-based and space-based telescopes to scan the skies. Every night, these instruments capture images of the sky, looking for objects that move against the background of stars. When a new NEO is discovered, scientists spring into action. They calculate its orbit to determine if it poses any risk to Earth. Section 8. Apophis, a case study in asteroid surveillance. One asteroid that has captured public attention is Apophis. Named after the Egyptian god of chaos, this asteroid caused quite a stir when it was discovered in 2004. Initial calculations suggested a small but worrying chance of impact with Earth in 2029. It was a wake-up call for the scientific community and the public alike. Apophis is about 340 meters in diameter, roughly the size of 4 football fields. An impact from an asteroid this size would cause regional devastation. The initial concern about Apophis led to increased tracking efforts and improved orbit calculations. As more data was gathered, the risk assessment for Apophis changed. Scientists now know that it will pass very close to Earth in 2029, close enough to be visible to the naked eye. Section 9. The Cosmic Lottery, Unpredictability of Space Events. The Martian mega-tsunamis and our ongoing efforts to track near-Earth objects, NEOs, highlight a fundamental truth. The universe is unpredictable and full of surprises. Cosmic events like asteroid impacts are often described as a kind of celestial lottery. We can calculate odds and probabilities, but we can never be certain about when or where the next big impact will occur. This uncertainty keeps scientists and astronomers on their toes. It's a humbling reminder of our place in a vast and sometimes chaotic cosmos, where we are just a small part of a much larger picture. This unpredictability is both terrifying and fascinating. On one hand, it means that Earth could potentially face a devastating impact with little warning, causing widespread destruction. The possibility of such an event is a sobering thought, reminding us of the fragility of life on our planet. The dinosaurs certainly didn't see their extinction coming. Their sudden demise serves as a powerful example of how unpredictable cosmic events can be. On the other hand, this unpredictability drives us to expand our knowledge and capabilities. It pushes us to develop better technologies and strategies to detect and possibly deflect these celestial threats. Our efforts to understand and prepare for potential impacts have significantly advanced our understanding of the solar system and our technological capabilities. We are constantly learning and evolving. The Martian mega-tsunamis serve as a stark reminder of what's at stake. They highlight the importance of our efforts to monitor and prepare for these unpredictable cosmic events. Section 10. Ripple Effects, How Impacts Shape Our Understanding. The discovery of Martian mega-tsunamis has had ripple effects far beyond the field of planetary science, influencing various scientific disciplines. It's changed how we think about Mars, impacts, and the history of our solar system, offering new insights and challenging old assumptions. These ancient catastrophes have become a lens through which we view cosmic evolution and planetary habitability, reshaping our theories. They're not just events in Mars's past, they're keys to understanding our cosmic neighborhood, offering clues about the conditions that might support life. One major impact, pun intended, has been on our search for life beyond Earth, expanding our criteria for habitable environments. The mega-tsunamis confirm that Mars once had large bodies of water, a crucial ingredient for life as we know it. and a significant finding. They also suggest that this water existed for long periods, possibly providing a stable environment for life to evolve, which is a groundbreaking revelation. The tsunami deposits might even preserve evidence of ancient Martian life, if it existed, offering a tantalizing glimpse into the past. The Martian tsunamis have also influenced our understanding of Earth's history, providing a comparative planetary context that enriches our knowledge.